All right, so let me restart back at our dynamic traffic assignment. So again, there are a couple of different ways that vehicles can get assigned different routes. So the first is using static assignment, which would be using vehicle inputs and static routing decisions. And then you can also assign these dynamically. So dynamic traffic assignment is the process of defining these different paths, which is going to be an iterative process, as it's going to take multiple simulation runs for Vissim to determine this optimal path assignment. And these paths are also going to be time dependent. So you could have a different path at 7 a.m. versus 5 p.m., or maybe a different one during midday. So what are some of the use cases for dynamic traffic assignment? DTA is really good for large networks that maybe don't have any predefined paths, and maybe there are multiple ways to get between all the different origins and destinations. And this is also a great tool if you're already receiving demand in the form of origin destination matrices, as that is one of the main inputs that will be needed for the DTA assignment process. So for the dynamic traffic assignment, we're going to kind of break this up into 3 parts and cover it over multiple tooltip sessions. So the first one today, we're just going to cover the network objects. And then next time we'll look at some of the DTA parameter settings. And finally, we'll look at the DTA results and then fine-tuning the network. So as part of DTA, there are kind of 2 groups of network objects. The first are those defined by the user, and the second are those defined by Vissim. So on the user side, the first thing that you'll typically do is build up all of your link and connectors and just build up your whole roadway network. And then from there, you can start to layer in all of the different DTA elements. One of the first elements will be adding in these nodes, which will be at any decision point, which will typically be any intersections or any merge or diverge locations, anywhere where vehicles need to make a decision. And then in order for the vehicles to actually get onto the network, we'll need to use the parking lot network object, which will act as a connector between the zones and the actual links. And then the zones themselves will actually be the main origins and destinations for the trips to get generated. And all of that demand will be contained within origin destination matrices. So once those have all been set up on the user side, on the Vissim side, the first object it will automatically generate will be turns within the nodes themselves. So this will be like the northbound left, northbound through, northbound right, etc. And then edges will get defined as different link sequences that exist between the nodes themselves. And then those edges will all get grouped together to form the actual path that vehicles will take between the origins and destinations. And finally, Vissim will also define OD pairs, which are really just groups of the origins and destination zones. For example, like origin zone 7 will be grouped with destination zones 8, 9, and 10. All right, so let's take a closer look at all of these elements that need to be defined. First up is going to be nodes. So again, these are going to be placed at any decision points that vehicles will need to decide what their next choice will be. So nodes are really just a polygon that can be placed around any of these locations. So for DTA, you'll need to place these at any intersections, making sure to include the turn base, and then also at any diverge and merge points. So nodes will be added by selecting the nodes network object on the left-hand toolbar. And then if you hold the control key and right click, you can kind of place that node start point. And then you can just left click to place all of these remaining points around that particular decision point. And then once you have your node selected, you'll just want to make sure you have the option to use for dynamic assignment checked. So some of the best practices for drawing these nodes. First off, all of the nodes will need to be placed at any location that vehicles will be entering or exiting the network. And we'll talk more about that when we get into the parking lots. And then again, these should also be placed at any merge or diverge points, and also at any intersections, making sure that the entire turn bay is actually encompassed within that node. And then when you're drawing these, you'll also want to make sure that the entire connector is included within the node. And so this can actually be easier to draw when you're in wireframe mode. That way you can see exactly where those connectors are starting and ending and making sure that they're fully enclosed. And then nodes also cannot overlap. So if you have two intersections that are kind of spaced closely together, again, another great option is to go into the wireframe mode just to make sure that none of your node edges are touching one another. All right, so moving on to our next network object. Here we're going to talk about parking lots. So parking lots act as kind of a connection between the zone demand and being able to place that demand onto the network. So first, just select the parking lots network object, and then you can right-click on a link and then just select that Add New Parking Lot option. So for any origin zone connectors, you want to place those near the start of the link, because this is where the vehicles will actually enter the network. And then for any destination zone connectors where vehicles will be leaving the network, those should be placed near the end of the link. So once you have that parking lot created, the parking lot window will open up. And the first item to check is make sure that you have the zone connector type selected. And then below that, you can select the zone that's associated with that particular parking lot. And right next to the zone option is where you can also add new zones. So if you're just creating these parking lots from scratch, you can quickly add different zones and then select them there. And then it's very important to update the relative flow value. So for any destination zones, since vehicles won't be entering the network at those locations, you'll need to set that relative flow to 0. However, for the origin zones, this will need to be set to at least 1. So say, for example, if you have zone 1 and it just has a single parking lot entry point, then you can set the relative flow to 1. However, if zone 1 maybe has 2 or 3 different parking lots, you can change the split percentage for the vehicles entering the network at each of those locations. So for example, you could have, if you had 2 parking lots, you could have a 50-50 split or maybe 75-25, just depending on how the vehicles need to enter the network. And then at the very bottom, you can set up the default desired speed. So this will be the speed at which vehicles will enter the network. And then below that, you can also add different speed distributions for all of the vehicle classes. So some best practices for adding in these parking lots. All of the origin parking lots should be placed downstream of that entry node that we talked about earlier. And then on the flip side, the destination parking lot should be placed just upstream of that exit node. And then you also want to make sure that you only place one parking lot between 2 nodes, as vehicles only need to enter at one place and then just leave at a single place as well. All right, so the next network object here are zones. So again, these zones act as the origins and destinations. So this could be things like residential areas or workplaces or schools, really any location that vehicles will travel from and go to. So the zones themselves are not a physical object, so you won't see these over in the Network Objects toolbar. But really, it's just more of a list that gets contained within Vissim. So to add these zones, you'll go to the Traffic tab, and then select dynamic assignment, and then go down to zones. And this will open up the zone list where you can add new zones and you can change the number and the name. And then again, you can also add these directly within the parking lot object itself, if that's a better workflow to use. And then finally, we actually need to create the demand for the vehicles to travel to and from each of these zones. And so all of this demand will be held within origin destination matrices. So these matrices will contain all of the demand information. The rows will represent the origin zones, the columns will represent the destination zones, and then all of the values in the middle represent the demand itself. So for example, if we look at this 28 here, this would be 28 trips that will occur going from zone 9 to zone 8. Or if we look at this trips 30 over here, this would be 30 trips going from zone 8 to zone 10. So all of these matrices can be added again under the traffic dynamic assignment tab if you select matrices. And then you can select the green plus button to add a new matrix. And if you double click on that, that will open up the matrix editor where you can actually enter in all of the demand for your origins and destinations. And then it's also very important to update the from and to time for that matrix. And the from time, which is when the time that this matrix will start, needs to match the simulation parameters start time. That way, as soon as the simulation begins, vehicles will be able to enter the network at that time. All right, so now we're going to move on to the automatically generated network objects for DTA. So the first one here is turns. And so turns are generated within nodes themselves. And this is really just another link and connector sequence for each of the turning movements that are set up within the node. And since these turns exist within the node themselves, if you open up the node list, you can view these by changing that child list dropdown to look at the turns dynamic assignment. And once that's selected, then all the turn information will show up in that child list. Now, if you're just running DTA and you just created your network and you haven't actually run it yet, none of these objects will exist. So if you right-click in that child list, you can just create that dynamic assignment graph, and that will force those objects to be generated. And then you can scroll through each of those and you can view where all of those turns are located. And within that window, you can also close different turns. So maybe like a U-turn you wouldn't want to allow. You can just select that close button and that will remove that option when vehicles are deciding what path to take. And then kind of moving up to the next level, edges are going to be the link and connector sequence between nodes themselves. And these edges can also be viewed through the node list. So again, you'll just change the child list dropdown to look at edges, and then you can generate that dynamic assignment graph if you need to. And then you can scroll through and view all of the edges that are assigned. And you can also check and make sure which edges are closed and open. And then all of these edges are going to get used to determine the actual paths that vehicles can take between origins and destinations. So all of these paths are really just built up of edges, a group of edges. And so all origin destination pairs need to have at least one path so that the trips can have a place to go to. But these OD pairs may also have multiple paths, which is what Vissim will determine when it's running through all of its iterative assignment results. So in order to view these paths, we'll go back to our favorite new menu here, which is under Traffic, Dynamic Assignment, and then Paths. And this will just open up the path list so that you can click through and check and see all of the different paths that are getting generated. And in order to view these paths, you will need to run Vissim at least once. The very first time you do this, it will just generate paths based on the shortest distance. All right, and then the final object here are OD pairs. And so these are really just the groups of different origins and destination zones. So like, for example, you could have 7 going to zones 8, 9, and 10. You could have zone 10 going to zones 7, 8, and 9, and so on. And so the OD pairs are really nice for looking at different aggregated results. So to view the list of OD pairs, again, you'll go to Traffic Dynamic Assignment and then select OD pairs object. And this will just open up a list of all the OD pairs that exist. And then when this really will come into play is when you go to the evaluation menu, where you can actually view the different results for each of these pairs. And this is another topic that we're going to cover more during part 3 when we look at the results. All right, so we have created a small example file here. This does have a couple of different path options for vehicles to take when they're traveling between different origins and destinations. So we haven't done much running with this network yet, so we haven't really fine-tuned any of the parameters or anything. But we have set up all of the parking lots, the nodes, and the zones and the matrices. That way, after this, you'll be able to download this file, and you can just kind of check out all the different objects and see how everything got drawn in. So let me go ahead and pull up that model here. So you can see so far we've really placed all the nodes again around the intersections at any location where you have any paths merging or diverging, making sure to enclose all of the connectors. And then we've also placed the parking lot objects at all of the network entry and exit points. So again, for the origin zone parking lots, we've updated the zone number and then set that relative flow value to at least 1. And then on the destination side, we made sure to go ahead and set that relative flow to 0, since no vehicles will actually be generated from that parking lot. So then I also just wanted to walk through and build up a node here for this intersection. So I have the nodes object selected here in the network object toolbar, and I'm just going to control right click to place that first point, and then just left click to place the remaining points. And again, when you are adding in these nodes, it is nice to kind of view this in wireframe mode, just to make sure you have all of the connectors encompassed. And then again, when you are doing this, you also want to make sure that you include the full turn bay when you're adding in all of your node points. And in this intersection, you can see the turn bays are pretty closely spaced together. So this is another place where you kind of have to zoom in and use the wireframe mode to make sure that the full turn bay gets included. And then I'll just make sure that use for dynamic assignment is selected. And then you can go ahead and adjust any of these points as desired to kind of clean this up a little bit. And so then again, if you do want to look at any of the automatically generated objects, all of those will be under traffic dynamic assignment. So you can select different things. You can also view the edges directly from this dropdown if you don't want to go through nodes. So again, I'll just kind of right click there and create that graph so you can kind of see all the different edges that exist between all of the nodes themselves. And then once you play that simulation, this is the first time it's running, so it's just going to generate an initial set of paths based on the shortest distance between all of those origin and destination zones. And then once that starts running, if you go back to traffic dynamic assignment, you can start to view those different paths. And so those will just be highlighted in yellow, so you can kind of see where all of those origins and destinations are getting assigned to. All right, so that kind of covers our DTA example.